So the Skill IDE features are basically, first of all, the definition of it is that it is an interactive source level symbolic debugger that helps you develop, test, and refine skill procedures. It's also a multi-file editor that provides a common editing and debugging environment. You can auto-indent source code, color syntax, highlight it, single-step execution through skill programs in order to debug them. You can set breakpoints so that the program execution stops at a particular location, and you can do this graphically with the mouse rather than inserting commands. You can trace and edit values of variables during execution and watch those values change as the code executes. You can display variable scope and also stack trace to see the hierarchy of functions that have been executed up until that point in the code. To start the Skill IDE, you will go to the Tools menu in the Command Interpreter window, pull it down and locate the Skill IDE command. It will then raise the Skill IDE debugging window.
Here we'll cover how to use the Skill IDE to debug a skill program. So first of all, the Skill IDE is used to develop and debug skill programs in Virtuoso. The flowchart to the right here shows the typical steps you would use to debug a skill program with the Skill IDE. There's a debugging workspace that will assist you. It sets up tracing program execution as well as tracing variables. There are other workspaces that you can use for different things like coding or for Skill++. But for debugging, there's a basic workspace, and you can, of course, mix and match additional assistance in that workspace if you like and make your own. And then what the Skill IDE allows you to do is to observe program execution by stepping through your code, and you can stop at preset breakpoints and observe both what's going on in the execution of the code as far as where it branches and what the values of the variables are. So looking at the flowchart on the right, what we'll be covering here in this section is, first of all, you're going to open a skill file for debugging in the IDE. You'll select the debugging workspace to get your assistant set up. Then what you'll do is you'll load the skill program. This is the same as if you loaded the program in the Command Interpreter window and it evaluated the program and provided you with feedback on any syntax errors. And then you'll have to analyze those and correct any. And again, you can do this within the Skill IDE. You don't have to go to a separate editor. Then what you'll want to do is, if you're trying to figure out an issue in your program or want to just observe what's going on, you can select some variables to trace, and it will be added to the Trace Assistant window. You may want to set some breakpoints so you can stop execution. You can do this interactively by simply clicking in the left-hand column next to the statement in the code that you want to stop at. Then once you've set up things for tracing and for breakpoints, you can run the skill function. It will then run to a particular breakpoint, and then you can step or continue. Step would be like a command at a time. Continue would be continue to the next breakpoint. And you can examine the code, what's going on, what parts of the code are executing, what are the values of the variables in the program. And then when you decide what you want to change in your program based on that, you can edit the source file right in the Skill IDE, save it, and reload it and rerun the program. So basically a loop here of, examining the output, making changes, and then rerunning it. So in the first step here, what we will do is open a skill source file for debugging. And so from the Skill IDE, you'll go to the File menu and select Open. It will provide you a browser where you can choose your file from the file system. So what you'll do here is open the skill.il file for your particular program. And now that file may contain multiple procedures. And then you can basically manage those in the IDE in terms of multiple tabs, for example. In step number 2, what we will do now that we've opened up a particular file for debugging, we'll select the debugging workspace from the Skill IDE. So you can see there's a menu selection here. And what that will do is load in several assistants, including the trace assistant, stack, breakpoints, and step result. So these are the default ones. You could add, for example, the Finder assistant if you needed that for helping you with writing some, adding some different functions to the program. The Finder will look up the syntax for you. And note some of them, some of the assistants, for example, the stack and the breakpoint, are basically grouped together, and when there's not enough real estate on the screen, it will create tabs. So you would click the breakpoint tab to bring that forward, or you could, again, grab them and slide them to a different point in your session, and they would be relocated then. So again, select the debugging workspace to begin the debugging process in the Skill IDE. In step number 3, what you'll do is load the skill code and check for syntax errors. So the loading of the skill code is the part where you actually, it would be similar to typing the load command in the CIW with a program name or a skill file name. So here, now that we've opened the file, we've set up our debugging workspace, we're going to click on the load icon noted there, the little gold circle with the half round arrow showing a load function. And what will happen then is if we do have some sort of a syntax error, we'll see it noted typically in the command interpreter window. In this case, our procedure definition has an extra white space, so we get information that we have an illegal formal list. And then also, it will also be highlighted typically in the command, in the Skill IDE source code pane. So you'll have 2 points at which to look at it. And then what you would simply do at this point is you could correct that error, remove the space after tr create inductor, and then save it and reload it. So again, this little part, you'll basically be correcting any syntax errors that the load command may flag for you. So in step number 4, you'll select variables to trace. So what you'll do is, for variables that you're interested in seeing the values for in the program, you'll basically go to them in the source code pane, right-click on them, and a pop-up menu will appear. And from that pop-up menu, you will select Trace. And this will place them in the Trace Functions and Variables section of the Trace Assistant, shown here on the right. And then as the program executes, as you're stepping through it when you run it, at any point in the program, you can observe the value of that particular variable. And it of course could change during the program, so you can see if the values change, if they're changing to the expected value. So this would be an alternative to, for example, putting print statements in your program that would print out the value of the variable at different points. So again, add those to the trace assistant, and then when you execute the code, you'll be able to observe it. So in step number 5, you'll be selecting breakpoints in order to stop program execution at that point in the code. So what you want to do is in the source code pane, on the left-hand side in the gray area, left-click in that column to the left of the code statement that you want to set or unset a breakpoint for. So if there's no breakpoint there, it will set it. It will be basically a red circle with a white hand icon that will appear next to that line of code. And if it had been set, if you click it, it will unset it. So now what will happen later on, we'll see, is when you run the program, execution will stop at that breakpoint, and then you can continue on to the next statement or next breakpoint as you desire. So in step number 6, you'll be running the function to a particular breakpoint, and then you can step through the code at that point from that breakpoint. So what you'll do in the Skill IDE is, from the menu shown, you'll select Run Function, and then in the field to the right, you'll actually enter the function call with the required input parameters. And then on the far right, once you've entered the function, you'll click the blue arrow to actually execute the code. And what will happen then when you run the skill evaluator, it will stop at the first breakpoint it sees. And you can see here when it stops, it highlights that particular line in yellow. And that shows you where you're at. You can go observe the values of the variables. In this case, if you look at the variables there, PT1, PT2, they've been initialized to nil in the let statement, but they've not had a value assigned yet. So as you progress through the code and step or continue on through the code here, values will be assigned to these. But at this point, you simply run to the first breakpoint and you're ready to then proceed. So continuing on in step number 6, where we are running the function to a breakpoint and stepping through the code. At this point, we've run the function and the code has stopped at a particular breakpoint. What we can do then is single step through additional lines of code after the breakpoint to see what's going on. And then once you've gone past a particular point in the code where a variable is set, for example, PT1 here was set to a value, you can then look in the trace window and see what that value was. Now, if you don't want a single step, you can also click on the continue icon, which is a blue double arrow. And from that point, it will basically execute all the code until the next breakpoint or the next error or the end of the program, whatever comes first. So again, you can either single step or continue on at this point. In step number 7, we'll be editing the source code, saving the changes, and then reloading those changes to continue testing our code. So first of all, in this section here, you're going to modify the code in the source code pane to fix the error. Then you're going to save the changes and reload the changes. You can see the two icons here. The save is the floppy disk and the reload is the gold circle with the arrow in it, which indicates you're going to reload it. So you do it in that order, save and load. And one thing to note here is when you've made changes but have not reloaded it, you'll see an exclamation point on that load icon to let you know that you really do need to load it to continue testing.
Here are additional Skill IDE assistants that are available in the IDE under the Window Assistance menu. They include the standard trace, stack trace, breakpoints, and step results assistance that you've seen previously in the debugging flow. In addition, there is a lint manager, a code browser. For Skill++, there's a class and method browser, and there's also the Finder and Profiler assistance. Now previously this list was part of the Skill Development Toolbox that was under the CIW menu. They are now included as assistants in this menu. The one you will still find under the CIW is the Finder, where you can launch the Finder from there, but these other assistants are now part of the IDE and you will need to use them as part of this environment. And in addition, the IDE has taken on the standard workspace functionality. What this means is similar to the design windows, these workspaces with assistants can be configured to whatever the task you are doing at the time. So you can make a workspace that includes, for example, the lint manager and code browser. And you can name that your own workspace. There are some built-in workspaces. As you can see, there's a window workspaces menu. So there are some default workspaces already created for you, for example, for coding or for debugging. So you can look at those also. In the Skill IDE, there is a go-to menu that you'll see, which is a go-to something. So depending on the context and where you're at, you'll have access, for example, to go to the source, go to the skill finder, go to the code browser, go to method browser, go to current line. So in the little example on the right, when you right click, up comes a menu choice, and you can, for example, say go to source, go to finder, or go to code browser. So very quickly you can hop to these various assistance. When you use the Show Tooltips when hover over Name option, it will allow you to show function arguments by hovering the mouse over the function name. It'll give hint completion for any function name you are typing, or will show you the values of the variable. So in order to enable it, you select Options Editor pull down from the Skill IDE. The Options form will come up with the Editor tab selected, and then what you will do is select Show Tooltips when hover over Name.
So in summary, in this module, you learned how to examine the Skill IDE use model, to step through a Skill IDE debugging session, and then to take a look at some additional assistance and options available with the Skill IDE.